Hello everyone, it's me Robin Koirala. Today I am going to present on the topic of energy and exergy analysis of Fermeuse wind farm. This project is done for the course Advanced Thermodynamics and the course instructor is Dr. Mahaburi and the presenters are me myself Robin Koirala and my colleague Sam Yadav. Now about the introduction of the wind power. Wind power is becoming increasingly popular due to its great scientific achievement in the field, making it more cost effective and efficient. A recent study shows that 273 terawatt hour electricity was produced from wind in 2021, which is 55% greater than the year 2020. And according to another report from National Renewable Energy Laboratory, the cost of producing wind energy has fallen since 2010 and is predicted to continue to decline in the year to come. In this report, we take into consider the Fermeuse wind turbine and did the thermodynamic analysis to find the energy and exergy of the wind turbine. Talking about the problem statement, wind turbine usage has recently increased due to its simplicity and clean energy. However, wind turbines are still designed and optimized with traditional technique which has limited their performance. A new approach is required to assess the efficiency of the wind turbine which can identify the significant areas of improvement within the system. So in this report, thermodynamics analysis of the wind turbine is done by taking in example of the Fermeuse wind farm. Talking about the objective, the main goal of the project is to conduct the energy and exergy analysis of the Fermeuse wind farm located in St. John's, Newfoundland. And the secondary objective are to analyze and compare the wind turbine exergy and energy efficiency, to examine the effect of environmental elements such as temperature, speed and pressure on the wind energy generation, to suggest the wind turbine design and optimization to produce the best possible energy and exergy efficiency. As I have already mentioned, Fermeuse wind farm of St. John's, Newfoundland is taken for the study, and energy and exergy analysis of the single turbine inside the farm is carried out in this report to learn more about the effectiveness and efficiency of those turbines. Table 1 shows the wind farm specifications and figure 1 shows the wind turbine input and output variables which are velocity, pressure and temperature. And about the meteorological data, we take the data from the NASA power project which is the prediction of worldwide resources, and the figure 3 and figure 4 shows the monthly average maximum and minimum temperature, pressure of and wind speed of Fermeuse town. Assumption and standard values. The variation in pressure and temperature at the turbine input and output are considered. Humidity impact is also considered. Wind stream is considered to be incompressible, one directional and continuous. Phase shift are not taken into account. Now table 2 shows the standard values which we consider for our calculation. Now for further presentation, I would like to pass the slides to my colleague Sam Yadav.
Hello, myself Sam Yadav, and I would like to explain the topic on the energy analysis and the exergy analysis. The first one is energy analysis. The energy balance equation for any control volume system can be written as in the equation number 1. And the rate of change of energy of a control volume with respect to the time represent the ratio of energy transfer within the control volume, and W represent the work effect which is comparable with the creating the power in terms of mechanical work by spinning the axis of wind turbine and producing the electrical energy by using the generator. Now under the steady state condition, the rate of change of energy of a control volume with respect to the time is equal to 0, and the equation as shown in the equation number 3. And the energy equation between the wind turbine inlet and the outlet may be expressed as in the equation number 4. Now, it is very difficult to find out the mass of air, therefore, the kinetic energy is expressed in the terms of density, and we know the density is defined as mass per unit volume. Finally, the kinetic energy in terms of density of air, swept area, time and the velocity is obtained from equation number 10. Now, exergy analysis. Exergy analysis can be defined as the maximum amount of useful work that can be obtained from a system, and it represents the capacity to do useful work. There are 4 kinds of exergy. They are kinetic, physical, potential and the chemical exergy. and it can be expressed as in the equation number 11. The potential and the chemical exergy are ignored due to the absence of the chemical affinity and the insignificance of the height variation between the turbine intake and the outflow. In this project, we will only consider the kinetic exergy and the physical exergy. In equation 17, the exergy of the physical exergy is shown, and the first term of the right side represent the enthalpy and the second represent the entropy contribution. Generally, the physical exergy should be calculated using the pressure and temperature across the intake and output. In equation number 17, the climatic factors are not considered, and it is very difficult to quantify the pressure and the temperature at the wind turbine entrance and the exit. Therefore, to overcome such a challenge, some research has been proposed to determine the physical exergy as shown in the equation number 18. Now, the energy and the exergy efficiency. The energy efficiency eta and the exergy efficiency psi are used to analyze the wind turbine performance. Energy efficiency is equal to E out by E in, it is shown in the equation number 19, and the exergy efficiency psi is equal to E out by Ex, that is given in the equation number 20. Now, keeping all the metrological functions, the energy efficiency can be written as shown in the equation number 21. Also, considering the power output from the turbine, the exergy efficiency can be expressed as in the equation number 22. If I talk about the tools used, the analytical methods are used to solve the energy and the exergy efficiency equation. After the necessary data is collected using the analytical method, the popular statistical software such as the Minitab and the Excel is used to analyze and interpret the result. And these software programs are highly regarded for organizing and presenting the data efficiently. Now, to discuss about the result and the conclusion, I would like to pass the slide to my friend Robin Koirala.
Thank you. Now I'll be talking about the result and discussion. As you can see in the figure 4, the figure 4 shows the energy and exergy efficiency of the wind turbine throughout the year. We can see that the energy efficiency is leading and the exergy efficiency is lagging behind, but have the similar pattern. The energy and exergy efficiency can be seen inclined for the month of May to October because the temperature is increasing in this month in the wind farm, and we know that the temperature is the major factor for determining the pressure and wind speed of the location. The energy efficiency ranges from 0.16 to 0.55, whereas the exergy efficiency ranges from 0.11 to 0.45 for the Fermeuse wind farm. The energy efficiency cannot precisely predict the system performance because it neglects many factors during the calculation, whereas the exergy efficiency is low because it is characterized by multiple meteorological variables such as change in entropy, enthalpy, internal irreversibilities, making it more accurate and reliable. Now, talking about the conclusion and recommendation, the study found that exergy analysis offer a more comprehensive and precise evaluation of how efficient a system utilizes energy, and is significant area to focus on to improve the system performance. Hence, exergy analysis is more critical than conventional energy analysis for assessing and enhancing overall performance. Furthermore, the result from the report, particularly for the Fermeuse wind farm, will aid the government agencies, researchers and engineers in adopting suitable plans and policies for wind turbine development. The Fermeuse wind farm energy efficiency ranges from 16 to 55%, whereas exergy efficiency ranges from 11 to 45%, with maximum efficiency in May and October. The energy efficiency is higher than exergy efficiency because energy analysis does not consider the meteorological effect such as air humidity, temperature and pressure. At the same time, exergy efficiency considers all the environmental factors and give a detailed analysis of the system. These are the references from where we studied different papers. They are all cited. Thank you very much for your time and consideration.